Hi, today we will discuss a laser frequency cam LFC generates cam of frequencies by following equation which is F true is equal to NFREP plus FCU. The light of LFC is capable in a frequency transform spectrograph FTS, and the FTS is used double-sided mode, which actually means that the optical path length difference OPD is changing from minus x1 plus minus x1, resulting in a symmetric interferogram. The interferogram is recorded with a detector and digitized. In a real experiment, you would get an interferogram that denotes intensity over displacement delta x. In the current experiment, I already switched the delta x into delta albeit starting 0 not using negative time. Each experiment did not take longer than 0.1 second. The total amount of the delta t does not amount to the 0.1 second. Some averaging already took place. The experiment was done 5 times every minute one. There might be a broken data. The LFC was switched off during measurement or something else prevented measurement of the light. Typically, a frequency stabilized LFC is very stable in the position of its spectral lines. The amplitude of the electric field may vary due to thermal effects. However, the stabilization may be compromised and there might be no thermal effects. This is our project and we have to do following tasks such as check signal, read them into code and plot them. Characterize the signal with regard to its properties, stationary, transient. Typically, it makes sense to describe different components of the signal individually. But in this video, we will do following tasks just like check the signals, read them into your code and plot them. So I already completed this project and I will explain how I did this project. So I open the file in MATLAB. Such as we already discussed that we did experiment 5 times every minute. Okay, I got a data like this is signal parameter time data, and the other one is signal data. You can see the data. Now let's we go to MATLAB and read the signals and plot them. First of all, we have to clear the previous variables in running in the MATLAB. To do this, we have to run the command clear all. Next, we have to clear the command window. For this, we have to run clc command. Next target is next task is to load the data from CSV file we already have, like 2 files. So to load these files, we have to use xls read commands. Okay, we run this command and let's see the output. and we rename the uploaded loaded file as signal parameter and signal per time. That is, you can see in signal there are five columns and 16,384 rows. So we already loaded the signals. Now we have to do our main task, which is check the signal and read them into your code and plot them. So for plotting, we have to run the command figure and subplot. I I use a variable subplot number to get the size of signal. Okay, our size will be 5 because we have 5 columns and we have 5 signals. Our signal number subplot number is like signals, which are 5 times. Now we have to plot. Let's see the signals by using plot command, and we keep time variable in the first input, and the second output is like x variable. We set time, and y variable we set signals. Let's run this command. Signal is processing, and to label the figure, we sorry did not run the figure command. X label we put time, and Y label intensity, title interferograms. Legends, because we have 5 signal, we put signal 1, signal 2. Let's see the graph. You can see graph. Okay. Second method display. This was first method. Now I am using second method, which is figure, and let's see. You can see here. I use for loop generate the signal from 1 like 1 to subplot number which are 5. So it will generate the subplots for 5 signal, 1 to 5. Subplot here I is generated like this. So x label is the difference is that here I plotted 5 signal in different plot. Like you can see here, there are two. See here, 5 signal in one window, and here 5 signals in 5 different plot, like signal 1, signal 2, signal 2. So this is the process to check the signals and read into your code and plot them. Okay, this was our first task. Next video we will discuss the characterize the signal with regard to its properties like stationary, transit. Typically it makes sense to discover different components of the signal. Okay, thank you.